Start. Okay. Hello everyone. Welcome back again to our channel Coders Arcade. This is Saurabh again, back with one more Java DSA live session. Okay. So today guys, we will be continuing from yesterday's classes, and what we will do is we will learn some more sorting algorithms. Okay. And this Java live playlist is dedicated to what? Data structures and algorithms. Okay. Myself Saurabh, and I will be guiding you through all the algorithms, and also we will be learning various data structures that are needed for your placements. Fine. Yesterday, if anyone has not gone through it, I will tell you that we have started learning sorting algorithms. Okay. The sorting algorithms that we learned yesterday were bubble sort, selection sort, and then we started with one very important algo that I was telling. It was count sort. Okay. Count sort algorithm. The first thing that I told you guys, I will just give you a short recap of what we learned yesterday, and what I will do is I will also open the thing in my own mobile so that I can see if you are commenting. Okay, because I might lose the comments that you are making. Okay. So, yesterday we were learning about a very special algorithm called count sort algorithm, and I had told you about the algo, how it works, but still those who are new today, I will again do a dry run so that we can understand about the algo, and then we will write the code. Okay. So, yeah, I think sir, please go through count sort logic again, maybe in high level if time is not enough. It's okay, I will do that, don't worry. Fine, I will do that. Thank you for reminding. I was planning that only, so I will do it. So, I said it is a non-comparison algo. It is used for single digit whole numbers, and I said what? The step 1 was to find the max, right? The max value. Okay. So, what I will do is I will draw the array that we had taken yesterday. So, this is my input array. This is my input array. Let us take the elements 1 3 2 3 4 1 6 4 3, because I said that it works on single digit whole numbers. So, that is actually 0 to 9. Makes sense? Now, what was the next step? To find the max. What is the max here? The max is 6. Okay. While writing the code, I hope everybody knows how to find out the max. Don't worry about that. So, max is 6, and then I said based on this, step 2 will be to do what? Create a count array from 0 to that max value. The index should start from 0 and end at 6, the max. Okay, let us create the count array now. Zero, 1, 2, 3, 4, 5, 6. Okay, let me write down 0, 1, 2, 3, 4, 5 and 6. Okay. So, let us count them. Simple, just calculate the count. Okay. The third step is calculate the frequency. Frequency is all the elements. So, there are no zeros. So, I will write 0 here. Let us take a different color. No zeros, so 0. 1. How many ones? 2 ones. Okay. How many 2's? Only 1 2. Only 1 2. After that, how many 3's? 1 2 3. 3 3's. How many 4's? There are 2 4's. Okay. How many 5's? There are no 5's in the array. 0. How many 6's? Only 1 6. Okay. We got the count. So, this is my input. This is my count array. I hope this is absolutely clear. There is no problem. Now, next step. The fourth step. As I told, I gave an example yesterday, something like this. This is the first person, this is the second person, say T, this is the third person. So, serial number 1, serial number 2, this should be serial number, say X, serial number 3. I cannot randomly write serial number 9 here. 1, 2, 3 should be followed by 4 only. When scenarios like this happen, you have to calculate what? What did I say? Because the current value 4 is dependent on the previous value 3. When this thing happens, you have to calculate cumulative count or cumulative frequency, because it is getting accumulated. Okay, say suppose there are 4 zeros, then the number 1 will come after this. The position will be after the 4 zeros. That is how the sorting algorithm is going on. Make sense? So, let me erase this part, not required here. Otherwise, you guys will get confused here. So, I will just erase this part. Got it? We have to calculate the cumulative count. But here, for the first person, say Saurabh, myself, do I bother about who is before me? I just come and sit here. If this is the bench, I just come and sit here. I don't bother who is there. This, I will be the first person, position number 1. Then someone comes, his or her position will be 2 based on my position. Make sense? That is why cumulative count. But for the first person, I am least bothered about who has come before me, because nobody has come before me. So, the cumulative count starts from index number 1. Okay. So, let me erase this. Let us calculate the cumulative count now. Let us draw the array. Zero, 1, 2, 3, 4, 5 and 6. Okay. So, let me write down the values 4, 5, 6. As I said, because the first value is not dependent on any previous value, this value will directly come here. So, let us take a different count, green color, 0 directly comes here, but the second value is dependent. So, 0 plus 2, 2, 2 plus 1, 3, 3 plus 3, 6, 6 plus 2, 8, 8 plus 2, 8 plus 0, sorry, 8 plus 0 becomes 0, 8 plus 1, 9. See, cumulative count, very simple formula, current equal to current plus previous. Hope you have understood this. Got it? No doubts, I guess. Current equal to current plus previous. For the first one, there is no previous. So, just put it here directly. Make sense? Okay. And you are doing the calculation left to right. Left to right. This is your cumulative count. Cumulative count. Make sense? Now, after that, the fifth point was output. Create the output array. Okay. I will just drag it a little bit up. This much is fine, or let me just reduce the size a bit. Okay, fine. Now this is fine, absolutely fine. Yeah. Now let us draw the output array. This is my output array, say suppose this. Same size, right? Same size as the input. 0, 1, 2, 3, 4, 5, 6, 7, 8. And guys, make sure one thing. This last number that you got, after counting all of them, should be equal to the length of the input array. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So, this last number that you are getting should be equal to the length of the input array. Otherwise, you have done something wrong in your calculation, as simple as that. Okay, hope you have understood this. Please make sure you remember this and understand this properly. Is that okay? Now, let us go and try to do this. So, as I said, we are taking the cumulative count from the left to right. So, while storing we start from the end of array. For the storing of the output we do this. Okay. So, now the first number is what? Let us take a different color. Yeah, the first number is 3. What is the total count or the cumulative count of 3? Tell me. The cumulative count of 3 is 6, right? 6, but we had added with the previous one. So, we had added with the previous index, just subtract one index, 6 minus 1 becomes 5. At 5th index in the output array, at 5th index in the output array, what do you do? Tell me guys, I had told you this yesterday. At 5th index in the output array, you have to store what? You have to store this particular value. So, I will store 3 here. Make sense? Now, let us move on to the next value 4. What is the total count of 4? See 8. 8 minus 1 becomes 7. 7th index, what do you store? You store 4. This particular value. Make a note of this, please do not confuse yourself. Now 6. What is the total count of 6? It is 9. 9 minus 1 becomes what? 8. At 8th index in the output array, store this number 6. Got it? Now next 1. Total count of 1. What is that? You can see it is 2. 2 minus 1 becomes 1. At first index, you will store 1. And it keeps on going like this. See, 6 is the largest number, right? It has automatically gone to its correct position. That is how it is working. Let us do it for the others. 4. Count. Tell me the count. It was 7. 7 minus 1 becomes 6. 6th index, I will store 4. Then comes 3. This number 3. 3. Count of 3 is 5. So, I will just write it here. 5 minus 1 becomes 4. At 4th index, I will store 3, this particular number. Then comes 2. Okay, 2. What is the total count of 2? It is 3. 3 minus 1, 2. Second index, I will store 2. Then comes 3 again. Let us take like this. Count. See, 5, 4, then this is 3. Third index, you will store what? Tell me. You will store this particular number 3. Only one element is left, right? Still, let us do it. 1. This is 1. 1 minus 1 becomes 0. 0th index, what will you store? 1. See if this is sorted or not. Check. 1, 1, 2, 3, 3, 3, 4, 4, 6. Sorted. That is how the count sort algorithm works. I hope you have understood this. Clear? Time complexity, I had already told you. Big O of n plus the max value. Linear time complexity. Okay, big O of n plus max. Is that clear? Hope you have understood this. Guys, any doubts, you can ping your comments in the comment section. Don't worry about this. Hope this is clear. Right? Now, let us write down the code so that we can understand the algo more efficiently. Fine? I don't think there is any comment from anyone, so everything is fine. So, let us do one thing. Let us get back to our code editor and let us write down. Fine. So, what I will do, I will just go to my algorithm sorting right now, right click and new Java class, say count sort algo. Count sort algo. Fine. So, here first let us write the count sort algo. So, public static void count sort. What do you need from the user? You just need the array, right? ARR. Tell me the steps one by one. First step, find the max, right? Let us suppose that the first element in the array is the max. Okay. So, int I am taking k as a variable for the max. Okay. K equal to ARR of 0. Fine. K is the max and I am considering the first element to be the max. What I will do? I will iterate throughout the array from index number 1 till last and see if any other element is greater, I will calculate the max. Fine. So, how do you do it? I will take a for loop for int I is equal to, I will iterate from index number 1, I will not compare 0 with 0, not necessary, and I less than ARR dot length I plus plus. How do you check? I can use the math library like this. See, I can say k is equal to math dot max. This is a built-in function. I hope you all know about this. Okay, I can take the k value and I will compare with all the elements in the array. Fine. Automatically, this method will give you the max of the entire array. Got it? Because I am comparing with the first element. Is that clear? Fine. This is how it works. After that, so we have found the max now. Guys, you can separate this logic and create another function to find the max. Okay. Not at all needed. I am doing it in the function itself or the method itself. Next thing, create a count array. Got it? Create a count array. Okay. Just remember this, guys, very important thing. What is the size of the count array? If you see here, the count array goes from 0 to 6. See here, it goes from 0 to 6 because 6 is the max, right? So, max plus 1. Our max is k, so k plus 1. So, I will allocate memory dynamically like this. See here what I am doing. I will say max plus 1. Okay. So, because it is actually why 0 to max, right? 1 extra. If you see the indexes, you will understand. 6 was the max. So, 1, 2, 3, 4, 5, 6, 7. So, max plus 1, 7 elements, right? How do we write? Int ARR or count, right? Count array is equal to new int of k plus 1. This is a dynamic array of k plus 1 size. Make sense? After that, what is the next thing that you have to do? Tell me. Calculate the frequency of all the elements. Okay. Calculate the occurrence of the elements. Very interesting point now. How do you calculate that? Let us go back here and try to understand. So, I will just drag this to this side and I will just teach you something now which will help you to write the code, otherwise you will not understand. See here, guys, say suppose I have the array like this 2, 4, 3, 1. Okay, this is my input array and this is my what to say the count array. What will be the maximum index of the count array? What is the max value? The max value is 4, right? So, 0, 1, 2, 3, 4. Make sense? Got it? What is the first element in the input array? 2. Where are we actually writing the value? We go to index number 2 in the count array because this is storing the count of that element, right? 2 index, correct? So, what do? We go to index number 2 and say I think something is stuck. Just a moment, guys. Yeah, now it's working. Yeah, what I was saying is we go to index number 2 and say plus plus. Got it? Again, next one 4 count. We go to index number 4 and say plus plus. Got it? We go to 3 index number C plus plus. That is what we are doing. How are you doing that? First you are going to the input array. Try to understand. we are going to the input array ARR of I. Suppose that number is 2. We are going to that particular index in the count array. Correct? And what are you doing? You are incrementing the count there. And this whole thing can be wrapped around inside a for loop, so that we get the count of all the elements one by one. Is that clear? That is how this algo is actually working. That is how you count them. You have lots of other methods, but this is one easy method to do it. Understood? First you take that number, which is that element, then go to the count array at that particular index here and say plus plus, increment that, and do it for all the elements by using a looping statement. Okay. So let us run this now. Anybody has any doubts, please ask. Okay, feel free to ask. So I will just go back and say for I equal to 0, I less than ARR dot length I plus plus. First we go to the input array, then we go to the count array and do what? At that particular index we say plus plus. Got it? With this we have calculated the count of all the elements in the array. Fine. What was the next step? Tell me, what was the next step? Let us go back here and go back to our logic that we had. What was the next step? See, after the count array, we need to calculate the cumulative count. But guys, cumulative count started from not index 0, it started from 1 and went all till C. Otherwise, you will get confused. The cumulative count is starting from index 1 and going till, what is this value? Max. Clear? Let us write down the code now. Back. I will write a comment. Calculate the cumulative count. Okay. So just remember this logic that I showed you. What was the formula? Current equal to current plus previous. Current equal to current plus previous. This you have to remember. Okay. So index number 1. Okay. For I equal to 1, I less than equal to the max value I plus plus. Current equal to current plus previous. This is the current value, count of I, plus is equal to count of, how do you write previous? I minus 1. Very simple. The current index is dependent on the previous index and the current index, the sum. That is how you write it. Is that clear? This is how you write it. After that, next thing, tell me. We have written all the steps, guys. The next thing, after cumulative, it is the output array. Create the output array. Okay. Create the output array. Yes. Int output is equal to new int of, what is the size? The size will be same as the input array. So I will say ARR dot length. Okay, I don't have any other parameter. I have the length of the array, input array, so I am taking that. Okay. Now tell me, guys, what is the next step? To store the elements, we start from the end of the array. That means ARR dot length minus 1, the last index. Correct? How do you write it? Tell me, anyone. I am waiting for your answers. Anybody, anything, please let me know. Start from the end of the array to store the output. Yes, simple. For I is equal to ARR dot length minus 1, because if the length is 7, it should be, index number will be 6, right? I greater than equal to 0, we are coming from the last index till the 0th index, correct? And obviously minus minus, I minus minus. Remember, let me just tell you once what we were doing. We were taking the last element, taking the total count of that last element, subtracting the index by 1, and then at this index we are storing that particular value. Got it? So, you are trying to relate the input and the output. So, I will write like this. See, we are trying to find a relation between our output and the input. Okay? The variable I is actually traversing for the indexes. So, I will write ARR of I and output of what? Let me just tell you. First, we are going to the input array. So, that is ARR of I. Correct. First, we are going to the input array. After that, where are you going actually? We are going to the count array to find the count of that element. Correct. See, we are going to the count array to find what? To find the count of that element only. We are going to the count array to find the count of that element only. See, 3, right? So, count of that element only. But before storing the array element into the output, what are we doing? We are decrementing the count by 1. Is it pre-decrement or post-decrement? This is pre, because first subtraction then storing, pre-decrement. So, you write like this, very simple. This is totally done. Got it? This is all about it. Fine, but now the point is, there is one last step that I will write, but before that let me go to the main function and just create the array. I will say int ARR is equal to, let us say 1 3 2 3 4 1 6 4 3, okay, and let us call the count sort function. And before that, guys, I will just show you that simple method where I can print the array in one single line. I will say arrays dot toString, what? Our array ARR, fine, and here I can just say before plus concatenation, simple concatenation, okay. So, after that what I will do is, I will call the count sort function and pass my array, got it, and then I will just copy this whole line again and paste it here. This time I will write after. So, guys, just remember one thing, we are not returning anything from this method, are we? No, it is a void. So, we are printing the same array here. See, we are printing the same array here. Let us see if it really works. It will not work actually. Let us see here. 1 3 2 3 4 1 6 4 3 1 3 2 3 4 1 6 4 3. It really is not working, right? Because the array goes call by value, not call by reference. Just in case of C or C++, it will go call by reference, because array considered as a pointer, but here array is not a pointer, it is call by value. So, what you do, from the output copy the contents back to the input, okay. One last line you can write, copy the output back to the input, because we are printing the original array only. So, let us, because the array has been modified, now let us copy it back to the input. How do you do it? Can anyone tell me how to copy an array? We can use a big for loop and do it. Other than that, is there any other way to copy an array? I am waiting for an answer for anyone. Please tell me. Is it possible to copy an array in one single line? From the output back to the input, can I do it? Can I copy? There is a very special method inside the system class. You can use that if you want, okay. In the system class, you have a function called array copy. So, system dot array copy, see what it takes. This takes the source position, the destination position, and the length, okay. The length here is same. So, I will write down like this, see, the source is our output array, the starting position for the index is 0, see output the source position, then the destination is our input array, this one, the destination position is also 0th index, and I need the length because both the arrays have the same length. I will just say ARR dot length. Okay. See, this is what I am talking about. The source position, the destination position, and the length of the array. In this case, both the lengths are same, so it doesn't really matter. Got it? Now see the output, guys. See the output. Is it sorted? It is sorted actually. See, 1, 1, 2, 3, 3, 3, 4, 4, 6. This is count sort for you guys, with the code explained, with the algo explained. Hope you have understood this. If you really understood this, please make sure you like, share and subscribe to our channel. Okay? And any doubts, any silly doubts, please post them in the comment section. Okay? And yesterday nobody commented regarding the codes. If you don't need the codes, it's well and fine. You just understand and that's fine. Otherwise, if you need the codes, I told you, right, you guys have to comment in the comment section even after you have watched the video. Then only I will share all the codes in a GitHub repository so that you can refer them and practice them for your own. Okay. Now, guys, count sort is done. Let's go to the next algo, which is what? A radix sort. A radix sort. This is also a very important algo, so make sure you understand this. And actually this is inspired by another algo, guys, which is called bucket sort. Fine. This algo is actually inspired by another algo called bucket sort. And count sort was working for single digit numbers. This algo works for multi-digit numbers. Okay, multi-digit numbers. And also this can work for constant length strings. Okay, this algo can also work for constant length strings. Okay, please remember this. So first step, just like count sort, the first step is to find the max. So let's take a random array now. One, 2, 3, 4 and 5. Fine. I am taking 5 elements, not more, just to understand, just to make you understand that. Fine. So let's write down. Say 325. I'll take 432. Then I'll take 261. Then I will take 12. And then I will take 9. Okay. These are my 5 elements. And why is it called radix sort, guys? Radix. Radix is actually the place value, the ones value, the ones, the tens, the hundreds, and so on. Radix sort deals with the place of that particular digit. It goes digit by digit and does the sorting algorithm. Okay, that's why this is also very popular in most of the placement drives. Okay, so hope you understand. Okay, we need the code, sir. Thanks. Yeah, Saddam Arbas says he needs the code. Fine, I'll do that. Now, And please comment guys, if you have understood the algo, if you are learning something new, if you are understanding those things, please comment that. Okay, it is really motivating for us. Otherwise it's like I am just doing something and nobody is listening to me, it feels like that. But if you are really listening and understanding, please motivate us by at least writing a comment that you are understanding. We need nothing else, we need some response from the viewers, that's all we need. Okay, so find the max is the first step, right? The max number is 432, correct? The max number 432. Now see here, 432, how many digits? 3 digits. So 3 iterations or 3 passes or 3 rounds will take place till it is sorted. Got it? Isn't it kind of crazy? Depending on the number of digits in the max value, this sorting algorithm will have that many iterations. Okay, so let's verify. Suppose the number was what, say 1000. How many digits? 4 digits, so 4 passes. Makes sense? That is how this algo works. Okay, now let's talk about the first pass, and before that, as I said, it is inspired by bucket sort, right? So create 0 to 9 will create 10 buckets. We will create 10 buckets. Let's do it. Yes. Zero, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Fine. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. As I said, it works with the ones place, then the tens place, then the hundreds place. So first I will take the ones place. So let's take a different color now, and see, this is the ones place value. This is the ones place, units place I mean. Okay, units, tens, hundreds and so on. So here, because the elements are not equal or the number of digits is not equal, for your reference you can take a 0 here, just for your reference, so that we understand that properly. Okay. Now first pass, do you have zeros? Check, do you have zeros here? At the units place, do you have zeros? I don't. 5, 2, 1, 2, 9, no zeros, so skip that. Do you have ones? Yes, we have one here. See, we have a 1 here, right? 1. So write it down in this particular bucket below, 261. Got it? Then do you have 2? We have 2 here, 432. We are starting from this side. Okay, so this is how much? 432 goes into this 2 bucket. Okay, 2 bucket. Next one, what? 0, 1, 2. So this will go here, 0, 1, 2. Make sense? Next, 3. I don't have 3. Do I have 4? I don't have 4. I have 5. 325. Next number, it is 009. 009. So others I am skipping. I am just writing 009 here. Is that clear? Let me just drag it a little bit to the right hand side. Okay. Just a moment, guys. Yep. So this is the first pass. Now let's write down the values here. One, 2, 3, 4, 5. We start like this and write 261 first, then we write 432, then we write 012, then we write 325. See, if the same bucket has 2 numbers, I am writing the first one first, then the second one, like this, in this order. Then next one is 009. Okay, this is iteration number 1. Done. Now I will just reset the counter because I don't need this again. Okay, just cleaning this up. Got it? Now pass 2. Pass 2 will take the tens place digit. This one, this one, this one, this one and this one, and repeat the same thing. Do you have zeros? Yes, I have a 0. So store it in this bucket 009. Makes sense? Easy, right? Then do you have 1? Yes, I have 1. So this is 0, 1, 2. Do you have 2 or any other ones? No, I don't have 2. Yes, I have 325. So yes, 325. So this is 3, 2, 5. Do you have 3? Yes, I have 432. So I am just writing them in that respective bucket. That's all, right? After that, I have 261, last one. I'll write it here in that bucket, 261. Okay, I am considering this individual digits. Okay, ones then tens. Okay, this is iteration 2 done. Let me write down the values now. One, 2, 3, 4, 5. So from here 009, 012, 325, 432, 261. Clear? This is iteration number 2. Now I will reset the counter. Let us write down for the third one. So first, as I said, ones done, tens place done, now it will be the hundreds place. Okay. So let us take a different color, yes, and hundreds place. This digit, this one, then this one, and let me just erase this, Control Z. Last one is actually this one, fine. Same steps you have to repeat. So 0, how many? 1, 2, 2. So this is 009, same bucket 012. Then do we have 2 here? Yes, 261. Do we have 3? 325, and then we have 432. Got it? Iteration number 3 done. Let us update the values here. Let me erase this and write down the diagram properly. Okay. You might be thinking, is it sorted, guys? Just check. Let me write down 009, then 012, then 261, then 325, and then 432. So this is iteration number 3. Is it sorted? 9, 12, 261, 325, 432. Sorted, right? And I said how many iterations? 3 iterations. See, 3 passes. 3 digits, 3 passes. Is it working? It is sorted. Okay. Hope you have understood this. Did you learn this? Have you learned this before? Please comment in the comment section. Okay, I think Virat said something and he deleted. It's okay. Guys, have you understood this algo? Now, can anyone tell me the time complexity? What is the time complexity of Radix sort? The time complexity is same as count sort. Big O of n plus the max value. This k or max you can write. This is also linear. Okay, and it works really good for smaller values. Linear time complexity. Okay, hope you have understood this. Now the main important thing here is Radix sort is called the brother of count sort. Okay, so here each iteration you will be calling the count sort function or the count sort method. Why? To calculate for the single digits. Okay, that is how it will work. Each iteration you will call the count sort function. Is that clear? So let's see how the looping statement will look like. See here. So I need to decide the number of iterations, right? So I am writing a for loop. Just try to understand. For int, for the number 432, how many iterations? This was the max value. How many iterations? 3 digits is equal to 3 iterations. How does the code decide that? Let me show you. Int, I will say a variable exponent equal to 1, and this is my max value, right? This is my max value. So I will say max divided by exponent is greater than 0, and I will say exponent multiply is equal to 10. This is the for loop that you will need. This is the for loop that you will need, and inside this for loop you will be calling the count sort function, and you will be passing your array, and then you will be passing your exponent value. Okay, that is how it will work. But how does this decide the number of iterations? I will tell you. Just see here, okay, and try to understand. What is the value of exponent in the beginning? 1. So what is the max value? 432. 432 divided by 1 is what? 432 only. So this iteration goes because is max divided by exponent greater than 0? This is greater than 0. So it works fine. Now what does exponent become? Exponent becomes exponent multiplied by 10. So it is 1 into 10 becomes 10. Let us go for the next one. So I will write again 432 divided by this exponent again, because you can see max divided by exponent. This time it becomes divide by 10. How much is it? Integer division. How much? 43. Got it? And exponent becomes what? Into 10 again, because this thing will keep on doing, right? Is it greater than 0? So this iteration also happens. Okay, first iteration, then the second iteration is happening. So this becomes 100. Now again the next number, same number, max divided by exponent. Let's do 432 divided by 100. How much? 4. Greater than 0, this iteration also happens. So one iteration happened when it was 432, the second iteration happened when it was 43, the third iteration also happened when it was 4. Got it? 1, 2 and 3. Let me write down with a different color. This is the first iteration, this is the second iteration. 432 is okay, 43 is okay, even 4 is okay. So third iteration, all 3 are happening. But after that, what does the exponent value become? Into 10, equal to how much? 1000. Now do this. 432 is our max, divided by 1000. How much are you getting? 0. Max divided by exponent should be greater than 0. Is it greater than 0? No, it is equal to 0. Stop. How many iterations? 1, 2, 3. Because of this particular logic. Understood? Now I hope you have understood about the count sort algorithm, also the Radix sort algorithm. If you can do this as a homework, I will be very happy, guys. Just try to do this as a homework and try to understand about this. Okay? Fine. If you get any problem, let me know. I will show you how to write the code in the next session. But you should also be practicing that. So that's why I am telling, please practice writing this code on your own using this particular logic, or else I also have a video on this thing in my YouTube channel, in our YouTube channel. Okay, what is that? You can just type Radix Sort Coders Arcade, Radix Sort Coders Arcade, and you will get that particular video. You can learn from there also. If you still don't understand, let me know in the comment section. I will again teach you that. Okay, no matter what, I will teach you. Don't worry about that. Okay, so this is guys about the Radix sort algorithm and the count sort algorithm. We have learned both of them. Fine, and the time complexity remains the same for both of them. So we have learnt bubble sort, we have learned selection sort, we have learned count sort, we have learned Radix sort. 4 algorithms we have done. If you understood this, if you love this, if you love the way I am teaching, if you have anything that you want extra, please let me know in the comment section. Otherwise, I will feel you are learning everything, understanding everything, so it is fine. So Saddam Arba says first term learning this algo. Yeah, there will be lots of things they will be learning for the first time, okay Saddam, but don't worry, we will be teaching you lots of things. Okay, so what is it? Okay sir, we do as homework and we do together tomorrow if there is any issue. Fine, no problem at all. Okay, so you have to practice guys every day, at least half an hour you have to sit and write the code, then only you can think about getting placed into a good company. Otherwise, you don't think that it's like bread and butter, people will come to your home and give you an offer letter. It's not like that. You have to practice, you have to sweat, then only you will earn your money. Okay, it's something like that. Got it? So now let's see the timings. I think we have enough time to understand the next algo. And guys, you guys have to comment if you are learning and if you are happy about the way of teaching. That is how I am getting motivated. Okay, and someone new to the channel, please subscribe to our channel guys. I have been saying this many a times. There are many people who just come, watch and go. Don't do that. If you really like the content, be there, stay with us, comment your suggestions, comment your things that you want, and please subscribe to our channel and also hit the bell icon because that will help you to get notified about the latest updates. Fine, thank you. So let's go to the next algorithm, one of the fastest algorithms in the world called merge sort. Today I will tell you the theory, but before that what I will do is I will try to give you a question which will help you to learn merge sort better. Okay. There is a very popular interview question that you get called merge two sorted arrays. Okay, this is a very popular interview question. So I have an array A1 is equal to 1, 3, 5, and I have one more array A2 which is 2, 4, 6 and say 7 and 9, something like this. Got it? So these are my two arrays that they have told you to sort, and the final array should be something like this: 1, 2, 3, 4, 5, 6, 7 and 9. This is the final array that you need after merging them together. Okay? So you can use any algorithm that you want. The best way to solve this is called a two-pointer approach. Okay, so let's create the third array A3 equal to, which will be the total of both of them, right? So 3 and 1, 2, 3, 4, 5, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so very simple. As I said, two pointers. I will take one pointer here, I will take one pointer here, and to store them into the array, I will take one more pointer here as k. Okay. So what I will do is very simple. I will check if our first array A1 of I, if this is less than A2 of j, initially both are at 0, see, A1 of I less than A2 of j. Is it true? Yes, it is true. So, what I will do? I will say A3 of k at this index, and it has to increment because I need to store the next element in the next index. So, k plus plus is equal to, then I will take it from the first one, A1 of I. Okay. So, let us do one thing, let us write this somewhere here, so that you guys do not get confused. So, I will take it here and write. This is the approach. Okay. So, what I am saying is, if the first array element is smaller than the second array element, I will store that into the this one. So, I will write 1 here, got it, and because I updated from here, I will increment my ith index. I will not do anything with the jth index, clear. So, this becomes what? I plus plus, make sense? And now check again, A1 of I, this is I, okay guys, A1 of I less than A2 of j? No. Then what will be the next one? A2 of j is actually less than A1 of I, the other one, correct? A2 of j is less than A1 of I. So, what I will do? I will store that element in the final destination array, got it? I will store that. So, 2 will come here, and which index will increment now? The jth index will increment, this will be j plus plus, make sense? So, whichever element is coming from whichever array, that index will be incremented and this will stay intact. Okay. If this is coming, I will go, otherwise j will go. Now, j goes here, fine. Is that clear? Now, check again, what happens now? Check 3 and 4. Now, the first one will come. So, automatically 3 comes here and I goes here, correct? And then again check 5 and 4. Now, j will come here because 4 has to come here. Is that clear how this algo is working? Got it? Now, after that just see what happens. Now, I have stored here and this comes here. Now, check this 5 and 6 I. What will come? 5 will come here, right? 5 will come, but now see here I has gone out of the array 1, gone. So, this will actually be in a while loop. While I less than length of the array, say suppose this is n and this is I can say n1 and n2, I less than n1 and j less than n2, got it? So, I has gone out, so this will stop. Now, I have completed storing this part and this part, no problem at all. Now, I have this pending. Do I need to sort them? Do I need to sort them? Absolutely not. I do not need to sort them because they are already sorted. The question is merge to sorted arrays. The array is already sorted. So, what do? I just copy the remaining part directly into 6 will come here, right? Then 7 and 9 will automatically come here. Is that clear? Got it? That is how this algo works, and this algo will really help you to understand merge sort. Okay? One of the fastest algorithms that we will be learning. Fine. Did you understand this? Please tell me. Did you understand this approach? If yes, then guys I will do one thing. Today we will be winding up on this only. We will be writing the code for merge sort tomorrow, and if possible I will be bringing some other sorting algorithms also for tomorrow. Okay? Guys, please stay tuned to our channel, and also please stay tuned to all the videos that you are uploading, and also stay tuned for all the live videos. And I think tomorrow is Saturday, I guess, right? So, I will just update in the Telegram, and yes guys, yes, please, if anyone is watching till the last, make sure you also visit our Telegram channel and join that, because all our updates are actually given there. Fine. So, I hope this approach is clear. Please make sure you try to write a code on this algo and try to understand how this 2-pointer algorithm is working, because this is the simple logic. Okay, and I said after any of the array is completed, if any array has extra elements, they will be simply copied into the final destination array. You don't need to do anything. Fine. I think Arvind says super. Okay, and Saddam says thanks. Thank you guys for being in touch and being live with us. It is really nice to have you all, and at the same time I'll just say please subscribe to our channel if you have not done that yet, and hit the bell icon so that you get lots of latest updates. Thank you for watching, and I will be coming back with another session on DSA where we will be learning merge sort properly, and also we will be learning about many other sorting algorithms and lots of things to come, guys. So stay tuned with us, and for the time being, this is Saurabh signing off. Bye bye and happy learning. Stay tuned, happy learning. Bye bye.